Hello friends, in this video we're going to look at problem 2947, Count Beautiful Substrings I. In this video we're going to explain a strategy to solve this problem. So we are going to reduce the problem to a prototype problem, and then we are going to use the dictionary and check trick. So first we are going to digest the problem requirements, and then we look at the connection of this problem with a prototype problem, and finally we look at the code. Now let's move to the problem digest. So here we are given a string s and a positive integer key. Let vowels and consonants be the number of vowels and consonants in a string. So here a string is beautiful if the number of vowels equals to the number of consonants. So this is the one thing. Another thing is that the number of vowels times the number of consonants is a multiple of the given integer key, right? So this problem is a counting problem. We want to find the number of non-empty beautiful substrings in the given string s. So here we have 3 examples. In the last example, because it does not contain vowels, so there's no beautiful substrings, so we return 0. Well, in the first example, the return is 2. So here we have A and E, so they are vowels. So we can have the BA. So this is a string that satisfies the first item, but it's because we have one vowel and one consonant, so it's not a multiple of 2 if you do 1 times 1, right? So we need to include the 2 vowels, so we can have BAEY, right? This is the one choice. So both the consonant and the vowels are 2, so we have 2 times 2, which is a multiple of k, that is 2. So we can also see AEYH, another one, so that's the 2 here. So similarly, you can analyze example 2 and get the output 3. So but here this is also very special, because here k is 1. So as long as the number of vowels and the number of consonants are equal, so they are valid. So here we can have AB, we can have BA, right? We can have ABBA, right? So those are the 3. So here the constraints are the following. First, the length is bounded above by 1000, and k is greater than or equal to 1 and bounded above by 1000, and s consists of lowercase English letters only, right? So with that said, basically we're ready to do the analysis. So here, as I mentioned, so we are going to translate this problem into a prototype problem, and then we are going to use dictionary and check trick. So the connection is the following. So because we are caring about the number of vowels and number of consonants, we don't need to specify which vowel or which consonant. So we can regard the vowels as the positive one and the consonants as negative one. Then we can translate or transform the string to be a list which contains ones and negative ones. Then the condition that the number of vowels equals to the number of consonants in the substring is equivalent to say that the corresponding subarray sum is 0, right? Then finding subarrays with sum 0 actually is a very standard type problem. For example, you can check the video for leetcode 560, right? So this is one requirement. Another requirement is that we need to have this multiple relation. So we just need to do an additional check, right? So that is, if vowels square is integer, a multiple of k, because the number of vowels and number of consonants are equal, right? So with that said, basically we are ready to write this code. But before we do this, let me first use the example 1 to give you some flavor. So here we have k equals 2, right? Then you can transform this s to be an array. So here b is a consonant, or I put it -1. A is a vowel, so E is a vowel. Then we have y consonant, h consonant. So this is the corresponding numerical array, right? So we want to find the arrays with sum 0, right? So it means the number of vowels and number of consonants are same. So this is 1, right? And this is also 1, and this is 1, and this is 1. Among the 4, there are 2 satisfy the second item, right? So with that said, let's look at coding. So notice that if you can first check out this problem, 560, and then try to do this problem yourself, it might be a good choice. But here I want to point out that typically in this problem 560, we just need to record the count of different prefix sums in the numerical array. But here I think we need to also consider the indices, because we want to consider the length of the corresponding subarrays or substrings. So here first I'm going to have a dictionary. So here the partial sum 0 is corresponding to the index -1. So I just put it here. Right, then we have an array. So let me translate that. One if character in this vowels, right? Else, so -1. So for character in S. So this is the standard list comprehension, which is super easy. So now we have this part. This is the preparation. And then we are going to initialize a result variable. So this result variable is a counting variable. So we are going to update this and return its final state. Then the current partial sum will be 0, right? So at the very beginning. Then we are going to do a for loop for r y in enumerate this array, right? And then the current will be incremented by y, right? Then we want to check if current is in D, right? If current is in D, it means that it's corresponding to a list of indices. Those indices starting after that up to this R, it corresponds to a subarray with sum 0, right? So then, starts, that's going to be D current. So here I wrote with some redundancy to help understand. Overall, the code is very short actually. So now what we want to do, those are the starts, right? So then basically what we want to say for L in starts, right? Then the length of the corresponding subarray will be R minus. So actually the starting indices should be L plus 1, because up to L we are considering the partial sum as the array from 0 then up to L, right? Then the current index for current, so we are considering from 0 up to R, right? So if these two sum are the same, right? So this is sum 1, let's see. This sum 2. It means that array starting from L plus 1 and then ending at R, so has sum 0, right? So this is the logic. So now this is the start end index. This is the start index. Then we minus that plus 1. Overall, it's R minus L. So this is the length, right? And then we know that for this subarray, so array from L plus 1 and ending at R, it has a sum 0, right? It means the corresponding number of resonants and the vowels are the same. Then we need to check another condition, that is the multiple modulo k equals 0 condition. So this is actually very simple, right? So we want to consider list over 2. So here, as long as the sum is 0, so the length must be even, right? So we can directly do this. If the square of this guy, so modulo k is 0. So this condition basically says that this array or these arrays are beautiful ones. So then we are going to increment the result by 1, right? So then after this, don't forget to update the dictionary, right? So we want to update the dictionary D current. So let's see, we use D get current. So we are going to save all the indices corresponding to a partial sum current, right? So if current not in the dictionary, we are going to use this empty list. Then we just append this index R, right? So now with that state, basically we can do return the result. So that's basically about it for this problem. Now before we make any comments, let's first do a test. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the generic cases. So now let's come back and look at the big picture. So as we mentioned that here, the important point is that we reduce the problem to a prototype problem. So here we map vowels to be 1 and the consonant to be -1. Then we transform the condition that the vowels and the consonant have the same frequency as that the sum of the corresponding subarray is 0, right? And then we just need to check the additional condition and see number of vowels times 2. Then our modulo k is 0, right? So this condition actually corresponds to half the length square over modulo k is 0, right? So I guess the main point here for solving this problem is that you can establish this connection of this problem with, say, this problem. Or if you practice quite a lot, you can directly have this intuition. That would be perfect, actually. So now with that said, I guess that's basically about it for this coding. So if you have difficulty in digesting the explanation here, you are encouraged to check out some other similar videos in our channel. So hope that will help. With that said, thank you.